Alright. NET-200. That was a Friday. Day 14 of the class. We started off base 10. We wrote out the base 10 number system. 10 to the 0. Anything raised to 0 power is 1. 10 to the first, 10 to the second, 10 to the third, 10 to the fourth. So, you know, when we have a number, you know, like 1 digit here and a 0 here, that's 10. 1 group of 10, 0 group of 1s. You put a digit here, it's hundreds. A digit here, that's thousands. Okay? And that's how we make numbers. And we can go in infinite direction this way by putting the digits 0 through 9 in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, and move one place over 10. Then we get up to 99, one place over, and we have 100. Okay? 1 over 10 to the first, 10th, 100th, and we can go infinitely small. So it's base 10 number system. This is what we use, maybe because we have 10 fingers, I'm not sure. The base 2 number system, binary, uses 2 digits. Base 10 uses 10 digits, base 2 uses 2 digits. And so we have 2's here. 2 to the 0 is 1, 2 to the first, 2, 4, 2 to the third is 8, 2 to the fourth, 2 times 2 times 2 times 2, 16, then 2 to the fifth, 32, 64, 128. Now I put in 8 because a lot of times we work with 8 bits gives us a byte, so a lot of times we work within that realm. So if we were to make a number and put the digits in, now we can only use 1s and 0s, so I put a 0, 1, 0, 0, 0, 0, 0, 0, 1. In base 10, that's 65. In the ASCII code, that's a capital A. If you're talking about what we use to represent the numbers, this would be a 66 base 10. Now we have one group of 2, 1 times 2 is 2, one group of 64, 64 and 2 would be 66. Base 10 number system. If we add all of these up, if we add a 1 inside every one of them positions, that would be 255 base 10. Okay, so then what we worked on a little bit is converting. You know, converting from base 10 to base 2 and from base 2 to base 10 so we can see what numbers represent. So probably the easy example would be look at some IP addressing. Okay, so we took an address from class. This is a work server in the classroom. And we took here, we took 172, and we took one group. Alright, so how did we get this? So we have, if we were to go back and look at, if I was to write out those other numbers, 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, 2 to the seventh. Okay, this would be 1, 2 to the first would be 2, 2 squared would be 4, 8, 16, 32, 64, 128. So then, when we were looking up here, 172, I took one group of 128. That's how that became a 1. I subtracted 128, different colors so you can see. Then I got 144. I cannot take a group of 64. Okay, can't take a group of 64, so I took a group of 32. That's where this 1 came from. Subtracted 32 and I get 12. can't take a group of 16, that's where the 0 comes from, but I can take one group of 8, that's where that 1 comes from. I subtract the 8, and now I have 4 left. One group of 4, and now I have 0 left. And so then I have zeros there. So this base 2 is the same as this. So then we did the whole thing. Did the whole thing here. Did them all. So this is the address us humans see, but this is the address the networking equipment sees, and the computer sees. All those 1s and 0s, 32 of them. That's what it sees. And we did another example here for the 85. Right there. 31 was pretty easy. Right there. So we should be able to convert back and forth binary to decimal and decimal to binary. Alright. So we finished up today. In NetACAD we took the Chapter 5 assessment, and we talked about being able to log, to configure a switch and put a workstation on a switch, testing wise. We finally too, we looked at the addressing over there where we showed all those 1s. We talk about the network part of the address and the host part of the address. So out on the internet, when we have these public addresses, they know to send this, so to speak, to our ISP, which then sends it to NIACC. When it gets to NIACC, this part comes to the IT area. So it's a public address. So we talked about the networking part of that and the mask that indicates which part's the network and which part's the host. Alright, to summarize then, we should be able to go from binary to decimal and back. When we have a binary representation of, for example, 8 1s, that would be the same as 255. In some cases, that counts. That would represent a broadcast address if we're talking about later on we'll talk about a MAC address. Okay, and then you also see it when we list the mask. 255, 255. If we have a mask like this part then would be the network, and all that would be the host. And that's it for today.